All right, discrete probability distribution module. This is kind of putting the probability stuff into real life and what it's used for, but we'll talk about probability distributions in just a second. So this first part just starts out by making inferences. So we're just using some different common sense stuff here. I don't think this is too difficult. In a recent study, 50 males used a new weight loss supplement, and all but 12 of them experienced weight loss after the 2 weeks. All but 12, so that would be 38 lost weight. I'm going to go ahead and write that right there. And 12 didn't, right? Because 50 minus 12. All right. In the same study, 25 females used the same supplement, and all but 2 of them, so that would be 23, lost weight, and 2 didn't. Just weird wording right there, so you got to be careful. All right, so fill in the blanks. The new weight loss supplement was more effective on females in the study. That is because only 8% of them failed to lose weight. I guess we didn't even have to do all that, but so this would be 2 out of 50 is, oh no, it's 2 out of 25, wasn't it? 2 out of 25 would be 8%, 0.08. This one, 12 out of 50 would be 24%. Okay, so that's because 8% of them failed to lose weight after 2 weeks, whereas 24% of the males failed to lose weight. So on this one, you're just comparing the different numbers. You just got to find the probability. And like I said, it's just taking the words, and you got to look at each of them like that. So yeah, 8% of them, the females didn't lose weight, and 24% of the males didn't lose weight, so it was more effective with the females. Identifying elements. All right. So like I said, these are just kind of doing some more real-life type studies that you look at. Identifying a 2-day video game had 8 contestants. The table below shows the information. Give the set of students who earned more than 3,800 points on the second day. More than 3,800 on the second day. It'd be all 4 of those, right? This does say given the set. So, I should have looked at the answer to this. I believe, anybody done this one yet? I believe you need to put it in brackets. Kira, Diego, Jane, and Away. Okay, I think you need to put it in brackets because it's a set. We'll double check that, but since it is a set, you got to list them all out. And then our other one, give the set of contestants who earned more than 1,300 on the first day. More than 1,300 on the first day. So this one, we would use Sally and Kira. So this one is really just reading the graph and putting it in set form. Shouldn't start too difficult on these. The next one says probability of an event and its complement. We already did that, right? No, maybe we haven't done this problem. I think I can do this. All right, so this one kind of walks you through how a complement and the probability works. You all know this in your head, but just to like see it written out is kind of nice. So you have these balls right here. The thing you got to pay attention to on this is this right here. Let X be the selected event that the ball is white, okay? So the ball is white at 1, 4, and 5. So my probability there would be 3 out of 5. The probability that it's not white would be 2 and 3. So that would be 2 out of 5. Okay. If I were to do 1 minus the probability of X, which is 3 out of 5, I would get 2 out of 5, right? That makes sense. So what this is telling you is that the 1 minus P of X is the same as 1 P of not X. We know this in our heads, but the probability of the original event plus the probability of the complement will always equal 1. So you can always do 1 minus that. Like if I told you the probability that we randomly select an American and they own a dog is 30%, then the probability that they don't own a dog is 70%. Like, y'all do this in your head all the time, but it's just kind of putting it in context. But yeah, filling out that chart, you got to fill out that chart by selecting which one's X. And the big thing here is making sure that you pay attention to what X is, okay? Because that will change on you, and you got to make sure you pick the right one. I think there's another one like that too. Oh, I might have taken that one out. Oh, this one messes with you, and it shouldn't, but it does. All right, so a discrete probability distribution. There are two rules to be a discrete probability distribution. I don't think we need any of that. The two rules to be a discrete probability distribution. The first rule is, like all probabilities, I don't know if I ever talked about this in this class, but we probably should for just a second. All probabilities have to be between 0 and 1, okay? All probabilities are always between 0 and 1, like 0% and 100%. 0, just a side note here, I guess, because I don't know if I ever wrote this out, but 0 probability, probability of 0 is, it's impossible. It cannot happen. Like, what's the probability I take a die and roll a 10? Well, I can't take one die and roll a 10 because it only has 1 through 6 on it, right? A probability of 1 is what they say for certain going to happen. I think is the word they use. The probability of 1, so like what's the probability I get a number less than 10 if I roll a die? I'm going to get 1, 2, 3, 4, 5, or 6, so it is going to be less than 10 for sure. Okay. Another quick side note here. Anything less than 5%, they use the word unusual. I don't think you ever see that in these topics, but just in case. So anything less than 5%, they would consider unusual. All right, so all probabilities have to be between 0 and 1 because 0 is impossible, 1 is for sure going to happen, and then you got everything in between. That's our first rule. Our second rule is all probabilities add up to 1. I need to make sure that all the probabilities are rounded correctly and add up to the number there. That is my two rules for a probability distribution. Okay. I was trying to think if I guess I could go over that right now. They do talk about this random variable X right here. They use capital X. They call it a random variable. So in this situation, my random variable is that I'm going to get -4, -3, 0, 3, or 4. Like, I don't know which one of those I'm going to get, but it is a random variable. So when you see capital X, that's kind of what they use that for. All right, now to actually do this problem. So the first thing is, like, to be a legitimate one, all these have to be between 0 and 1. Well, they're all all 0 to 1. They're all positive. They're all decimals. So we're good right now. But now I have to come up with two numbers right there to make them be a probability distribution or a legit one. I know that these have to add up to be 1. So if I add these up, 0 plus 30 plus 19 plus 16 is what, 49, 65? Is 65, right? These all have to add up to be 1. So if I do 1 minus 0.65, that leaves me with 35, okay? Now here's the weird part. These two have to add up to be 0.35. The weird part is it does not matter what you use. They just have to add up to be 35. So like I'm going to use 0.10 and 0.25. But you could use anything you want to there. Does that make any sense at all? When you look at the directions, I don't feel like they explain that very well, that you can use anything you want to. Like if she decides to use 30 and 5 and I do 10 and 25 and he does 17 and 18, like that's fine. As long as they add up to be 35, all of these will add up to be 1, so we're good. Okay? So they're all between 0 and 1, and they add up to be 1. So you can pick any numbers you want that add up to be 35 on that one. And they always give you 2 to do on here, so it's always going to work like that. Subtract those, add those up and subtract them from 1, and then they have to, the 2 that are missing have to add up to be that number. All right, this is just reading the chart, I believe, so I don't think you'll have too much trouble with this. Find the probability for the number described on a random greater than or equal to 5 would be these two, right? So 0.12 plus 0.11 is 0.23. Lower than 3 would be these two. It does not include 3. So if I add those up, I get 0.46. So you just got to pay attention to what it says there. Just a couple words that may help. If it says at most, it is less than or equal to. If it says at least, it is greater than or equal to. So sometimes that messes with you a little bit on those, but just pay attention to whether it's less than or greater than, or it includes it or not. And that one shouldn't be too bad. Okay, so the hard ones on this section are the introduction to expectation. Oh, this one's not hard, I don't think. Oh, no. So I told you that this always works out to, they call it the law of large numbers. If we flip a coin 10 times, we usually won't get 5 tails, 5 heads. We may get 3 tails and 7 heads, but if we do it, 500 times, we'll get pretty close to 250 heads and 250 tails. If we do it 5 million times, we'll probably get 2.5 million heads and 2.5 million tails. Like the longer you do it, the more it's going to come out to those theoretical numbers. So we talked about that a little bit. So expectation or expected value is where you have a certain number right here and you kind of project it forward to see what would happen. This is used a lot. I'll go into that more in the next problem, I guess. But this is just kind of the basics of it. And it says there are... Hold on just a second. Let me zoom back out. Does it tell us? Nope, we got to add those up, I think. Okay. All right, so we do not have the total number of students in this chart right here, so I'm going to add those up real quick. 35 plus 26 plus 24 plus 25, that is 110. 3, 5, 7, 9, yeah. Okay, so that's our total amount right there. Based on the above information, how many students on campus would be expected to prefer movie A or movie B? So movie A or movie B would be 35 and 26. All right, so 35 plus 26 is 61 out of 110. 61 divided by 110 is 0.5545. Oh, whoops. Okay. So 55% of this one little random sample that we did like movie A or movie B. But we're trying to figure out if we had a different campus of 900 students, how many are going to like movie A or movie B. So this is what we do in stats. So we do a small sample, and then we use that number to project forward. So if there's 900 on this other campus, we know about 55% of them are going to like one of those movies. We could take 900 times that number and you get about 4099.09. We can't have 0.09 of a student, so it's about 499 students. Okay. So you kind of, like you said, you do a sample and then you can project it forward when you have a lot bigger number there. So that is kind of what the expectation is you can use that to project forward and get those different numbers. Let me try another one here just to make sure it doesn't get any harder. I don't think it does. That's kind of the same problem. So on this one, we're talking about pizza, thick crust or stuffed crust. So if you're running a business, you may take 1 week's sales. Okay, the total of this is $924. What is it? Thick crust and thin crust. I guess I can just write it out real quick instead of trying to talk and remember all the numbers. So this is used a lot when you're doing a business. Like you have to do ordering for the next week and figure out how many, crusts you're going to need for the next week. So if I add these all up, it's $924. And I'm trying to figure out how many thin and thick crusts should order next week. It's thick and stuffed. I'm sorry. I keep saying thick and thin, but it's thick and stuffed. Thick and stuffed would be 234 plus 176. 234 plus 176 is 410. Okay. 410 divided by 925 is about 0.4432. So I know 44% of my pizzas are thick or stuffed crust, right? But next week, maybe there's an event coming into town, so I expect to sell 1,500 pizzas instead of 900. So how many, if I know 44% of those are going to be thick or stuffed, I multiply it and I get my number here, 664.8. Do not round, intermediate calculations. So 410 divided by 925 times 1,500. Yeah, it's probably 0.9, but I'm guessing we would just say 665 on this. Let's solve it. 666. Did I add up something wrong? Man, now I got to go back and add all my things up. 328 plus 234 plus 176 plus 186. Oh, it's 924. I put 925. All right, did I? Must have typed something wrong. 328, 234, 176, 186. Okay. Total is 924, which changes answer to 6. That's fine. All right, so you can use that number to project forward. We do that a lot. Expected value is something that they use a lot. Actuaries, if you've ever heard of something like that. I'm glad I clicked solve there. I don't want to do that one to start. Okay. An actuary kind of figures out how much risk is involved and how much money you have there. This is really big in insurance companies. How much money do we need to charge per policy? Like if you're doing a life insurance policy, like if a 40-year-old woman has a 99.8% chance of making it through the year. But what happens to that 0.2% that when I have to pay out $1 million life insurance policy, then I have enough money to cover it. And I can figure out how much I should charge based on the averages there to make sure that we're covered that $1 million there. So you can use these numbers to figure out your risk and different things like that. I should have looked at the explanation before I did this. I got the answer, so we can double check. I don't like the way the explanation does this because my brain doesn't work this way. So I may do it a little bit different than the explanation. I guess I got the answer right here, so we can make sure I do it right. But a MotoWin Auto Superstore is thinking about offering a 2-year limited warranty for $915 for all of the certain models. The terms of warranty would be that MotoWin would replace a car free of charge under certain specified conditions. Replacing the car in this way would cost them $15,700. Okay. So if I am going to cost them $15,700, I'm going to write negative because we're losing that money. We're working for the company. Suppose that under the warranty there is a 6% chance that MotoWin would have to replace the car. This is a probability distribution. Okay. Here you have the money. Here you have the probability that you lose or spend that money. There's a 94% chance that they wouldn't have to replace the car. If they don't replace the car under the limited warranty, the company is going to make $915, right? Because if I pay for the warranty and I don't use it, the company just pockets that. Okay, so this is like a normal or a discrete probability distribution chart where we have the money and the numbers here. This is the way that I do it. Alex is going to do it a little bit differently, but we should get the same answer. Because I think the company's losing this much money. Oh, wait. I forgot one thing. Why is this number wrong? They're losing they're replacing the car for $15,700, right? But how much would they actually lose? But they did pay for the warranty, didn't they? They paid for the warranty, so $915 minus the $15,700 is actually negative $14,785. So I'm going to change this number because we wouldn't lose that much. We would lose negative $14,785. All right. So to find our answer here of how much money we were going to lose or gain on the long run, okay? It's okay if we got to replace a few cars as long as we're charging enough for the warranty that if we sell 1,000 warranties and we only have to replace one of them, we're good. All right, so what I do here is I'm going to multiply both of these numbers. This is a weighted average, so I multiply both of these, and I get negative 887.1, and then I'm going to do 915 times 0.94, and I get 860.1, and then you add these up. Why can I not get... Oh, I'm sorry. So that is negative $27 on average. So if we price the warranty at $915, and there's a 94% chance that they don't replace it, and there's a 6% chance that we're going to lose that $14,000, we will actually lose about $27 per warranty that we sell over the long run, okay? So we probably would need to up the price of our warranty to $925 or $950 or something like that to make sure that we are making money on the warranty and not losing money on the warranty. That's the way that I do it. And again, Alex is going to do it a little bit differently. I don't know if their way or my way is easier, to tell you the truth. There's another one that I want to do. That's the one I want to do, but I don't want that to come out as my answer. I wanted a positive one, but that's fine. So at the bottom, undo. At when you pick your answer, there are three options there. The company expects to make so much money on each camera sold based on their warranty, how much they lose. But the third option is they're going to break even. So if you do get zero, like that just means they're going to break even on their warranty selling, okay? On this one right here, I won't read it all, but they make a profit of $300 per camera. Let me go black here. All right, they make a profit of $300 per camera. If the camera breaks in the first 2 years of purchase, they'll replace it for free of charge. Replacing a camera in this way costs the company $4,600. Sorry, I was hesitating there because I think I want to do the same thing that I just did. We got to subtract the $4,600, but we made $308, right? So let's do $308 minus the $4,600 would be negative $4,292. Okay, here's the weird one about this one. There is a 5% chance that it will need to be replaced once. That was this number. But there is also a 2% chance that I'll have to replace it twice. So I would lose another $4,600, and that would be negative 8892. Right? So I might have to replace it once, I might have to replace it twice, so I got to do that 4,600 twice. And then there is a 93% chance that we won't have to do anything at all. So let's hope this works out right when I did that. All right, so I'm going to multiply 308 times 9.93, and I get 286.44. 4292 times 0.05 is 214.6. That is negative, though, because I am losing that money. And this one, 8892 times 0.02 is negative 177.84. And then we add these up. So 286.44 plus negative 214.6 plus negative, oh man, I just cleared it. 286.44 minus 214.6 minus 177.84. Yes, I got it right. Minus 106, okay? So since that is negative, we expect to lose $106 per camera. So this is where, like an actuary, a quantitative analysis, somebody would come in and say, hey, we're losing money because our cameras are breaking so much. So instead of charging for 308, let's charge more. We got a bad product that breaks all the time, so we're going to charge more. Sounds about like America, right? So they would say we're only making $308 per camera. We need to make a little bit more so that we can make sure that we are making money on this product. So that is, like I said, that's the hard part of that one because you do have to do it twice, but you would do it the same way as the other one. You would just have to, you make $308 and you lose $4,600 for the first warranty, and you lose another $4,600 for the second warranty. Okay, so you have to set up those charts and then you multiply the rows and add them up. Again.